Hello, this is Dr. Morgan again with Clovis East High School. We're going to look at lesson 1.3, solving equations with variables on both sides. We're going to look not only how to solve equations with variables on both sides today, but we're also going to finish the lesson by looking at those equations that either turn out to be identities and have infinite solutions, and those that turn out to have no solution at all. So that's what's on task for today, so let's get started. In our two-step equation, you may remember that we had just one variable on one side of the equation, either the left or the right. What do you do when you have variables on both sides, like our example here? I have a minus 5x on the left side and a 4x on the other. Well, to solve equations with variables on both sides, we can use the properties of equality and inverse operations to write simpler equivalent equations. Our key strategy is to use these inverse properties to get all the variables on one side. One thing that students sometimes make a mistake here, you may remember that when we talked about combining like terms, and I emphasize that you can only do it on one side or the other side of the equation, not on both sides. Remember I talked about drawing a wall down the equation. Notice here, if I drew a wall down the equation and the left side has a variable and the right side has a variable, what you absolutely cannot do is say, oh, minus 5x and 4x is minus 1x. You cannot combine terms across the equation. When we do anything across the equation, we have to use the inverse property to eliminate the variable on one side and move it to the other side of the equation. You'll see this as we do it. So in other words, one of my other tips I do, because students so often will lose the negative sign, I usually, when deciding, do I want to move the minus 5x or the 4x, I choose whichever is the smallest numerically. In this case, the smallest, negative 5, is smaller than positive 4. So we're going to undo the minus 5x. The reason is so that we end up with a positive coefficient for x. Just means less chance of losing it. So we're going to add 5x to both sides of the equation to move the variables over to the right side. So notice there, minus 5x plus 5x is 0x, so that goes away, and I'm left with 8 equals 9x minus 10. So now by doing that, now we have a two-step equation, just like we worked on before. So this is easy. First step, undo whatever is added or subtracted to the variable. So we have a subtract 10, so we're going to add 10 to that side. And now we have 18 equals 9x. Now we're going to undo 9 multiplied times x. We undo the multiply by 9 by dividing by 9, both sides again. Always have to do both sides. And we end up with 2 equals x, or I could flip it around and say, oh, that's x equal 2, and now we're done. We have a solution. But notice above, to get the equations on one side, we chose the smallest one, minus 5x. We undid that one, and that ended up eliminating it from the left side, so we only had variables on the right side. It doesn't matter whether you get the variables on the left or the right. Like in this problem, we ended up with 2 equals x, but I can just use the converse and switch it around and make it x equal 2, and I have my answer. Okay? Let's do one more example in your workbook, and then I'll let you go on the own problems. So let's look at the first problem on your worksheet. Notice again, I have a 5x and a 2x. The 5x is on the left side. The 2x is on the right side. This is our given equation. As I said, it's easier if we make sure that we take the smaller one. So 2 is less than 5, so let's undo the plus 2x by subtracting 2x from both sides. Okay? So notice then 5 minus 2 is 3x plus 2 equals 14. Now I have the variable on just one side. And now we're down to our two-step equation. First step, undo the addition or subtraction. So we undo plus 2 by subtracting 2 from both sides. We get 3x equals 12 now. And now we undo 3 times x by dividing both sides again by 3. And we end up with x equals 4. Okay, let's check our answer to make sure we got it right. How do we do that? We simply plug x equals 4 back into the equation. So 5 times 4 plus 2, Does that equal 2 times 4 plus 14? Notice I put the 4 in for both x's because there's an x in both of them. So let's simplify that. So we have 20 plus 2 equals 8 plus 14. They both equal 22 equals 22. So I know I got the equation right. All right. So now you have a couple of problems that you're going to do on your own. I'll try to give you a little hint on each of them if I can. Notice in this problem that I have a minus 3c on the left and a positive 1c on the right. Which is the smallest one? If you think of a number line, negative 3 is less than 1. So you want to undo the minus 3c first by adding 3c to both sides. Here our two variables are 7k and 4k. You can undo this by undoing which one is smaller, 7k or 4k. Undo that one first. All right, we have a negative n on one side and a positive n on the other side. If you're confused about which one's smaller, put the 1 in there to understand this is negative 1n and positive 1n. So negative 1 is less than positive 1. So you would want to undo the subtract n by adding n to both sides. In the following two problems, we're going to look at solving an equation with grouping symbols. Now, we've done that before on one side. We're going to show you a more complicated problem where we have to undo the grouping on both sides, and then we end up having to also get the variables on one side. So it's kind of a combination problem. So from what we learned 2 lessons ago, I'm going to apply the distributive property to eliminate the grouping symbols. So notice 3 times 5x minus 5 is 3 times 5x is 15x minus 15. And that's going to equal on the other side, negative 4 times 2 is negative 8. And negative times a negative, don't lose your negative signs in here, is a positive 8x. Now you see we have an equation. Don't have a two-step yet, but we have an equation with variables on both sides. So I look at it and I say, which was smaller, 15 or 8? 8's smaller. So let's undo this by subtracting 8x from both sides. All right. Now you see we have a two-step equation. Now we know exactly what to do. We undo the addition or subtraction first. So we undo subtract 15 by adding 15. And then we undo multiply by 7 by dividing by 7. And our answer is x equal 1. And we have our answer. All right, then let's work the problem 5 in your worksheet. Again, we're going to undo the grouping, and then we're going to get all the variables on one side. So our first step, there's our given problem. Let's use the distributive property. 2 times 5x minus 1, and 3 times the quantity x plus 11. So we end up with 10x minus 2 and 3x plus 33. Now I have an x variable on both sides. So which is bigger? The 10. The smaller is 3. So let's subtract 3x from both sides. This allows us to remove the variable from the right side, and we only have a variable on the left side. Notice now we have our two-step equation. So we're going to undo the subtract 2 by adding 2. And now we're going to undo the 7 times x by dividing by 7. Again, remember, adding 2, subtracting 2, dividing by 7, we always do the same thing to both sides of the equation. If you don't do that, then it no longer becomes equal, and the equation is bad. So now we end up with x equal 5, and that's our answer. So this problem you're going to do on your own. So you're going to multiply 4 times the quantity 2y plus 1 to get rid of that parentheses on the left. On the right, you're going to multiply 2 times y minus 13 quantity to get rid of the parentheses on that. Then notice you're going to end up with a y on each side. You're going to have an 8y on the left and a 2y on the right. So you'll subtract from both sides the smaller one, and then you'll have a two-step equation. Good luck. Finally, we want to talk about identities and equations with no solution. Notice in the first one, an identity. Here's a sample equation. An identity means that the equation is true for every possible value of the variable. So notice if I solve this, x plus 1 equals x plus 1. If I subtract the x from both sides, the x's are gone, and I end up with 1 equal 1. I always say in class, when does 1 equal 1? And the answer is all the time. See how it doesn't matter what x is, it's always going to be 1 equal 1. So note if we solve this equation, we end up with a true statement, a statement that's true all the time. And if that's the case, if you end up with the variables gone in a true statement, this is an identity. It means no matter what variable I put in for x, that is always going to be a true statement. On the other hand, an equation has no solution if there is no value of the variable that makes it true. Okay? Most of the time we're solving equations, you remember, we're ending up with one answer, x equals 2. There's one answer. But these two are cases where either it's true all the time or it's never true. Notice in this equation, x plus 1 equals x plus 2. When I subtract x from both sides, I end up with a statement 1 equals 2. When does 1 equal 2? Absolutely never. So if we solve this equation, we end up with a false statement. When I get a false statement like that, I know, oh, this equation has no solution. So let's take a look at one of each of these. So here's our given equation. So we look at it, first thing you want to do, we have some parentheses on the right side, so let's do our distributive property to get rid of that. So 2 times 5x is 10x, and 2 times 6 is 12. So I end up with 10x plus 12 equals 10x plus 12. At that point, you should be going, wait a second, those are exactly the same, but let's continue on anyway. Let's get all the variables on one side. So I'm going to have a 10 and a 10. I'm going to subtract 10x from both sides to gather all the variables on the left side. All right, so that, but oh, what happened there? Notice that my variables went away on both sides, so I ended up with 12 equals 12. Now that is always true, no matter what x is, 12 is 12. So that means in this case, we have an identity. So this equation is true for all values of x. It is an identity. All right, let's try one more. Here, notice we don't have any grouping symbols, but what I do have to do first is I need to combine variables on each side. So on the left side, for example, I can combine the 12m minus the 3m is going to be 9m. And on the left side, I'm going to have a minus 3m plus 12m. So in each case, they both turn out to be 9m minus 4, and then 9m plus 5. Notice what's going to happen when we try to get the variables on one side. If I subtract 9m from both sides, I end up with a false statement. Negative 4 does not equal positive 5. So in other words, there is no variable that's going to give me the solution that I need. So this is no solution. All right. So I have two more questions, two more for you to try on your worksheet. So in this one, you're going to want to undo the grouping with the distributive property, and then you're going to want to get the variables on the same side and see where you go from there. In this one, you're going to undo the grouping symbols with the distributive property. All right. So just remember, just think of this as having a 1 right here. This is negative 1 times that, and so you're going to distribute that there and there. Multiply both of them by negative 1. Be careful, a negative times a negative is a positive. Finally, let's do a quick overview of the whole process of solving multi-step equations. In each case, we do simple steps to get it simpler and simpler until we finally get to our answer. So for example, this question here, on the left side, I notice that I have a grouping symbol. On the right side, I see something that needs to be combined. But first of all, remember that what we have in an equation is we have one expression on the left and one expression on the right. And when we say they're equal, that's what makes an equation. So now the first thing we always want to do is simplify the expressions on both sides before we start going across the equal sign. So we're going to do the left with the distributive property. Get rid of the grouping symbol. So 3 times x plus 4 is 3x plus 12. On the left, we can combine terms. So we're going to combine 2x plus 3x, and we're going to get 5x plus 8. Now we have simplified the left and the right. So now our next step is to get all the variables on one side. In this case, I'm going to do the opposite of what I told you before. In this example, I actually subtracted 5x from both sides. Now, usually I would subtract 3x from both sides to end up with a positive number. Notice what happens, though, if I subtract the other side, it still works. It's just that when I do this, I end up with a negative 2x. It just means when I get ready to undo the negative 2 times x, I got to make sure I don't lose my negative term. So now once I got the variables on one side, now we're down to a two-step equation. So we use our inverse operations to undo the addition or subtraction first, and then to undo the multiplication division. So to undo plus 12, I'm going to subtract 12 from both sides, and I get negative 2x equals minus 4. Just a note here, I've had some students who, when they look up at this equation, before that, they would say, well, I'm going to subtract 8 from both sides. Well, you could do that, and you'd end up with minus 2x plus 4 equals 0. Now, that's only a problem because some students will lose the 0 when they do weird things here. And remember, our goal is to get everything away from the x. The 8's already on the other side from the x. We don't want to mess with the 8. We just want to undo the 12. Now, at this point, we want to undo the minus 2 times x. So to undo minus 2 times x, I'm going to divide by minus 2. If you divide by just positive 2, you'll still have a negative. You need to undo the negative as well. And so then we end up with our answer, x equals 2. All right. Good luck on your assignments.